Welcome to the new session. So last class we have done with the alpha ray scattering experiment. So today we are going to discuss the new atomic model that is called Rutherford atomic model. What is meant by Rutherford atomic model? Why it is called as a solar atomic model? What is the size of the nucleus, volume of the nucleus, size of the atom, volume of the atom. So all these things we will learn in this session. So first you can see that Rutherford model 1911 on the basis of scattering experiment, alpha ray scattering experiment, Rutherford proposed a model which is known as a nuclear atomic model. This was similar to the solar atomic model. So after the J.J. Thomson model of the atom, Rutherford have done with the experiment that is called as a alpha ray scattering experiment. After the alpha ray scattering experiment, he has given some conclusion. Based upon that conclusion, Rutherford proposed the one atomic model. In this atomic model, he said that positive charge is concentrated in the center. Positive charge is nothing but nucleus. Nucleons are present. So that's why this is called nuclear atomic model. This nuclear atomic model is similar to the solar atomic model. Why it is similar to the solar atomic model? So why it is called nuclear atomic model? That all things we will learn in the coming points we will learn. You can see an atom consists of heavily positively charged nucleus where all protons, neutrons are present. Neutrons and protons are collectively called as a nucleons, they are called. So if you see that what this point, how we have to understand this point is, so we know that atom is a rounded shape. So center of the atom, if you see that center of the atom, heavily positively charged nucleus is present. You can see that this is the atom center of the atom, positively charged nucleus is there. So here, this is called nucleus. In the nucleus, neutron plus protons are present. So center of the atom, positive charge is present. Why it is having the positive charge in the sense? In the nucleus containing the nucleons. What are the nucleons? Nucleons is nothing but neutron and proton. Neutron doesn't have any charge. Proton having the positive charge. So that's why it is having the positive charge. So these two are collectively, this means neutron plus proton, these two subatomic particles are called nucleons, we are called. That means we have to understand this. Nucleons are present in the nucleus, it is present. Second one, almost whole mass of the atom is contributed by the nucleus. The magnitude of positive charge on the nucleus is different for different atom. So we know that we have the three subatomic particles, we have electron, proton and the neutron. But J.J. Thomson saying the second point is whole of the mass of the atom maximally contributed by the nucleus engine. This means how we have to understand. For example, if you see the mass of the electron 9.1 into 10 to the power of minus 28 grams. Mass of the proton, if you understand, 1.672 into 10 to the power of minus 24 grams. Mass of the neutron is equal to 1.675 into 10 to the power of minus 24. So I have given all the mass of electron, mass of the proton, mass of neutron. So on this board, you can see that which is having the more mass. So here when compared to the electron, proton having the mass highest mass, and proton and when compared to the proton, neutron slightly having the highest mass it is having. So here you have to understand that mass of the proton and mass of the neutron is nearly equal. So mass of the proton approximately equal to the mass of the neutron. It is approximately equal. But if you see that mass of the electron is very less when compared to the mass of the proton and neutron, mass of the electron is very less. That means you can write the next point also, you can write like mass of the proton approximately is equal to the mass of neutron is greater than the mass of the electrons itself. That means mass of the proton and mass of the neutron having the greater mass when compared to the mass of the electron. But mass of the proton and mass of the neutron, that means proton and neutron present in the nucleus, it is present. So most of the atom having the mass contributed by these two only, two subatomic particles. What are the two subatomic particles? Proton and neutron. This proton and neutron present in the nucleus. So obviously nucleus having the highest mass when compared to the atom. Okay, that I think you understand this point very well. So once again I am telling, mass of the electron is very less, mass of the proton and mass of the neutron is having the highest mass when compared to the mass of the electron. These two subatomic particles, mass of the proton and neutron present in the nucleus, those are called as the nucleus we are calling. This nucleus is contributed the highest atomic mass. Most of the atom mass is contributed by the nucleus only. That means when compared to the atom mass, nucleus mass is very high. The volume of the nucleus very small. The volume of the nucleus is very small, and it is only the minute fraction of the total volume of the atom. Nucleus has a diameter of 10 to the power of minus 12 to 10 to the power of minus 13 centimeter, and the atom has the diameter order of 10 to the power of minus 8. See, in the second point we have learned that mass of the atom, maximum mass of the atom is contributed by the nucleus only, it is contributed. So the mass of the atom is concentrated in an atom, very small portion it is contributed. That means volume is very small. In this small portion only, very small portion only, nucleus is present. That means volume of the nucleus is very small when compared to the diameter of the atom. So if you see that diameter of the atom, if you take the rate, how many times it is greater, if you see the how many times it is greater, so diameter of the atom and diameter of the nucleus, once you check the diameter of the atom and diameter of the nucleus, so diameter of the atom upon the diameter of nucleus. So you can see diameter of the atom they have given 10 to the power of minus 8. Diameter of the nucleus they have given 10 to the power of minus 10 to the power of minus 12 to 10 to the power of minus 7. So you will get 10 to the power of 5 times it is greater. So atom, this means you have to understand that volume. So volume is nothing but 4 by 3 pi r cube. So 4 upon the 3 pi r cube of atom is the greater than compared to the 4 by 3 pi r cube of nucleus. So atom having the highest, atom having the large volume, nucleus having the small volume is there here. So even though mass is high, that mass is concentrated in very small region, very small space, volume is very small, but mass is highest mass, nucleus mass. So I think you understand this point. See the next point. The radius of the nucleus is proportional to the cube root of number of the nucleons. So nucleons is nothing but number of the neutron plus proton. So number of we know that number of the neutron plus proton is equal to mass number. So you can write this radius of the nucleus is proportional to the cube root of nucleons. If you remove the proportionality constant, r is equal to r naught a 1 by 3. Here r naught value is equal 1.13 into 10 to the power of 13 to 1.14 into 10 to the power of 13. You can take the value, in between value you can take the value. Okay, this is minus 13. So approximately you can take R naught is equal to 1.13 into 10 to the power of minus 13 centimeters. So this is you have to remember. I think you understand this point. The radius of the nucleus is proportional to the cube root of number of the nucleus. So nucleus is nothing but neutron plus proton. So the sum of the neutron plus proton number is also called as a mass number we are calling. That's why R directly R proportional to the A 1 by 3. R is equal to R naught A 1 by 3. We know the R naught value we know. See the list part. There is a empty space around the nucleus called extranuclear part. In this part, electrons are present. So if you see that center of the atom is occupied by the density positive charge. So in the positive charge, neutron plus protons will be present. So we have 3 subatomic particles. So out of 3 subatomic particles, here neutron plus protons is present. That is only we are calling it as a nucleons we are calling. So here you can see that there is a empty space around the nucleus. If you see the nucleus, there is a empty space is there. This empty space they are calling it as a extranuclear part. This is called extranuclear part. So in this empty space, electrons are present. That means electrons are present around the nucleus they are talking about. Around the nucleus, electrons are present. Okay. So here if you see that volume of the atom, the nucleus having the small volume is there. So nucleus is responsible for mass of the atom. Only it is responsible for the mass of the atom. The extranuclear part. You can see the next point. As the nuclear part of the atom is responsible for mass. That means nucleus having the highest mass. If you want to calculate the mass of the atom, that means you are giving the more. It is responsible for the nucleus. So nucleus is responsible for the mass. But whenever you are talking about the volume, you have to consider the extranuclear part where electrons are present. Because when compared to the nucleus volume, extranuclear part of the volume is high. So there are the 2 parts in their atom. First one is called as a nucleus. Second one is called as a extranuclear part. So there are only 2 parts. So first one is called extranuclear part. Second one is called as a nucleus. So nucleus is responsible for the mass. Extranuclear is responsible for the volume of the atom. That means here you have to understand this. So the extranuclear part mass is less than the nucleus mass. That means nucleus having the highest mass. So extranuclear part having the volume is greater than the volume of the nucleus. So nucleus having the very small volume even though it has the highest mass. So now you can see that next point. The volume of the atom is about 10 to the power of 15 times the volume of the nucleus. So how we will understand this one? We can see that volume of the atom upon the volume of the nucleus. So we know that 4 by 3 pi r cube upon the 4 by 3 pi r cube. You can calculate the volume with the help of this formula. So from this you can write. So 4 by 3 get cancelled. Only radius will be there. We know the radius of the atom. So 10 to the power of. We know the radius of atom 10 to the power of minus 8 upon the. So this is the 10 to the power of minus 13 will be there. So we are talking about the radius we are talking. So upon the 2 we have to do. So this is the diameter as well 10 to the power of minus 8. So I am taking it to the whole cube. So you will get the 10 to the power of 15 you will get. So that means what? 10 to the power of 15 times. So 10 to the power of 15 times the volume of the nucleus. That means here you have to understand volume of the atom. Volume of the atom is greater than the volume of the nucleus. Nucleus having a very small volume, but mass is very large, small mass. See the next point. Electrons are revolving around the nucleus in a closed orbit with a high speed. So last point we have learned that in an atom, center of the atom nucleus is present, around the center of the atom some extra space is there. That extra space we are calling it as a extranuclear part we are calling. So this is the nucleus, this is called as the extranuclear part. In the extranuclear part, electrons are revolving around the nucleus in a closed orbit with a high speed. So around the nucleus, electrons are revolving around the nucleus with a high speed they are revolving. So this closed path he said that it is called it as a orbit we are calling. So around the nucleus, electrons are revolving in the extranuclear part with a high speed. That extranuclear path we are calling it as a orbit we are calling. So whenever the electron is revolving, what type of forces will be there? So that we can see here the centrifugal force acting on the revolving electrons. So whenever the electrons is revolving, some force will be there, that is called as a centrifugal force will act on mv square by r. It will be act. So one type of force is acting at the same time. So the force acting on the revolving electron is being counterbalanced the force of attraction between electrons and nucleus. So electrons having the negative charge, proton having the positive charge. There is a attraction will be there. That is called as a force of attraction, electrostatic force of attraction. You can see that these electrons, negative charge electrons is attracted by the positive charge of the nucleus. So nucleus in the sense plus Ze charge, electron having the E charge. So between some force of attraction will be there. That is called as electrostatic force of attraction. So that is called as a K Q1 Q2 by R square. Here Q1 is the electrons revolving the electron charge. Q2 is the proton charge. Proton charge I have denoted with the Ze. So what they are saying is the centrifugal force acting on the revolving electrons. So the centrifugal force acting on the revolving electrons is being counterbalanced by force of attraction. So force of attraction, electrostatic force of attraction between the electron and nucleus. So for centrifugal force in the sense mv square by r is equal to force of attraction in the sense k q1 q2 upon the r square. So here you can from this you can write that k q1 q2 by r mv square will be right. But here k is the constant, E is the electron charge. So that is E coulombs I am writing. Q2 is the plus Ze charge. Ze is nothing but proton charge I am writing. So Ze. So this by R is equal mv square. So from this you can write mv square is equal k Ze square by R. So the two forces acting on it. Electron is revolving around the nucleus. Some force is acting, that is called as a centrifugal force. The opposite one force is acting, that is called as the electrostatic force. Both are balanced. That's why atom is the stable. So like this, Rutherford explained some postulates about the Rutherford atomic model. So electrons is revolving around the nucleus in a circular closed orbit. So same like it is replicating like a solar model. That's why it is also called as a solar model. How planets are revolving around the sun, same thing here also electrons are revolving around the opposite charge, that is called as a nucleus. That's why this model is related to the solar atomic model. That's why this model is also called as a solar atomic model we are calling. So Rutherford atomic model also having some drawbacks is there. Before going to the drawbacks, we will see some important two numericals. So first one is calculated the density of the hydrogens they are asking. So we know that density is equal mass by volume. So mass of the electrons we know, mass of the hydrogen nothing but proton we know. What about the volume? Volume is equal 4 by 3 5r cube. That means we want the value of the r, we want the value. But Rutherford atomic model has given the one formula, r is equal R naught is equal A 1 cube root of its nucleus. So R is equal R naught in the sense 1.13 into 10 to the power of minus 13 centimeters into atomic number is 1. So 1 upon the 3. So you will get that R is equal 1.13 into 10 to the power of minus 13. You will get this. So you can substitute the R value in this. Mass we know, mass of the hydrogen is equal mass of the hydrogen, we know the mass of hydrogen. So 1.672 into 10 to the power of minus 24 grams. This is centimeter cube. So automatically density will get in the grams per centimeter cube we will get. So mass is equal, density is equal 1.66 into 10 to the power of minus 24 grams upon the 4 by 3.14 into 1.13 into 10 to the power of minus 13 cube, centimeter cube. So by simplification you will get 1.68, but approximate value is equal to 10 to the power of 14 gram per centimeter cube we will get. So this is the approximate value of the density of the hydrogen. See the one more numerical. Calculate the radius of nickel nucleus. So nickel nucleus we have to calculate. So we know that it is very simple. R is equal, R naught is equal A upon the. So R is equal, R naught in the sense 1.13 into 10 to the power of minus 13 centimeters. A in the sense 64 on the 3. This we can write like this, 1.13 into 10 to the power of minus 13 is equal, 3 get cancelled, so approximately 4 into 10 to the power of minus 13. So radius of the nickel nucleus is equal 4 into 10 to the power of minus 13 centimeter. So R is equal 4 into 10 to the power of minus 13 upon the 100 is equal 4 into 10 to the power of minus 15 meters. So I know that 1 vermi is equal 1 into 10 to the power of minus 15 meters. So R is equal 470. So Rutherford proposed the atomic model, even though he couldn't explain some points, he couldn't explain like a J.J. Thomson. Of course, electrons are revolving around the nucleus in a circular path with a high speed. J.J. Thomson said that electrons are stationary. Okay, so here he discovered the nucleus. Electrons are revolving around the nucleus. So he had given the explanation for the mass and volume of the atom. So he couldn't explain some point. With whatever the points we can see, this theory could not explain the stability of the atoms. So he also said that whatever the magnitude of the positive charge is there in the atom, for specific atom, the magnitude of positive charge is equal to the magnitude of the negative charge. So positive charge and negative charge. Okay, but problem is here. According to Maxwell, electrons loses its energy continuously in the form of electromagnetic radiation. As a result of this, electron should lose its energy at every turn and move closer and closer to the nucleus following the spiral path. Now we can see how to understand this one. You can see that, for example, this is the nucleus. So around the nucleus, some extranuclear part will be there. In a closed path, closed orbit, electrons are revolving. So these electrons are revolving in a closed path. Electrons are revolving in a closed path. Rutherford said that electrons are revolving around the nucleus in a closed circular path with a high speed. With a high speed they are moving. The high speed. According to the Maxwell, electrons loses its energy continuously. So continuously in the form of electromagnetic radiation. So electrons continuously moving with a high speed. Any body is moving with a high speed, definitely after some time it loses its energy. So Maxwell, according to the Maxwell theory, electron should lose its energy in the form of electromagnetic radiations. So automatically what will happen? So electrons will revolve around the nucleus if it is having the energy it is having. So it will revolve around the nucleus. So it will having the energy. So suppose if it is loses energy, automatically you don't have it loses the energy. So completely it will come closer and closer. So I am talking about this nucleus. So it will come closer and closer to the nucleus and it will ultimately fall into the nucleus. It will be fallen. So that will result atom will be like a unstable. But atom is the stable. If you see the practically atom is stable. But Rutherford is saying that electrons are revolving around the nucleus in a circular path with a high speed. Any object is moving around some object. So here, electron is revolving around the nucleus in a circular path. It is moving. So it is moving. So continuously it is moving. Whenever it is moving, so after some time, what will happen? It loses its energy in the form of a electromagnetic radiation. When it loses the energy in the form of electromagnetic radiation, so it will come closer and closer to the nucleus. Ultimately, result will be falling into the nucleus. So atom would be unstable. But atom is existing. So this point he couldn't explain the point. So that means it indicated that electrons are revolving around the nucleus, but it is not with a high speed. Something he didn't explain. See the next drawback. The electron loses energy continuously. The observed spectrum should be continuous spectrum. So, according to the Maxwell, electrons are revolving around the nucleus with a high speed. Okay, Rutherford said that electrons are revolving around the nucleus with a high speed. But whenever the electron revolving with the high speed loses energy, continuously it will lose energy. If it is loses continuous energy, the spectrum also should be continuous. It should be matches the energies. But here what happened? The observed spectrum, whatever the observed spectrum, practically the actual spectrum consists of well-defined lines of definite frequency. This means it is not matching the postulate. The observed spectrum, whatever the spectrum obtained actual observed spectrum, it is not matching the postulates of the Rutherford. So Rutherford said the electrons are revolving around the nucleus with a high speed. So whenever it is revolving with a high speed, continuously it loses energy. So when continuously it loses energy, in the sense continuous spectrum you should get. But what actual spectrum is? Definite lines of the spectrum with a definite frequency. So regarding the spectrum, what is the mean by spectrum? Different type of spectrum, continuous spectrum we will learn in the upcoming session. That is called a Bohr atomic model. After the Bohr atomic model we will learn. So hence loss of energy by electron is not continuous in an atom. Actual spectrum is different. Whatever we expected the spectrum is different. So automatically whatever the Rutherford said that regarding the energy, that is the incorrect. So hence loss of energy by electron is not a continuous. It is not a continuous energy losing energy in an atom. Next one, this theory could not explain the distribution of electron. He only said that electrons are revolving around the nucleus in a circular path. But how many electrons is there in the first path? How many electrons is there in the second path? How many electrons is there in the third path? What about the subshell? What about the shells? He didn't explain anything. So this is about the Rutherford drawbacks. So next session we will discuss about the electromagnetic waves. After that we will discuss about the Bohr atomic model. In the Bohr atomic model he explained about the spectrum of hydrogen spectrum, different type of the spectrum, distribution of the electrons. So thank you for watching.